So guys, we are going to move on to the next section. So next part is dividing polynomials. We're kind of like building. Section 5.4, 5.5, 5.6 kind of gets us into looking at things that don't factor beautifully and like what do we do from there. So like we start by working on dividing, and then like eventually we get to where we're using the graphing calculator and we're finding nice answers by looking at the graph, and we're using that along with the dividing I'm going to teach you today and kind of putting it all together to solve for all the answers. Yay. So today's kind of like one of those building block steps. There is two types of dividing we're going to look at. There is long division. Think back to what, 4th grade? My son's in 3rd and hasn't learned it yet, so I'm assuming 4th grade is where long division came in. I'll refresh with regular old numbers before we get to the algebraic ones just to make sure you're okay. And then there's synthetic division, which I was going to wait until tomorrow to teach synthetic, but I may show it to you today just because I'm going to be missing 9 of you tomorrow, because you're going to want to make sure you know how to do synthetic. It's not hard, so you want to make sure you know how to do it because we use it a lot in 5.5 and 5.6. Okay, but we're going to start with long division, and we're going to start with back to old-fashioned, way back when we had just plain old numbers, just to kind of refresh your memories. Okay? Don't tell me you never learned, because that's a bold-faced lie. Okay? I hate when people say that. I know you learned. You may not remember, but I know you learned. So starting with long division. How many times does 3 go into 6? 2. That's what we write on top. And then you multiply this. 2 times 3 is 6. And then what did you do? You subtract. 6 minus 6, 0. And then you would drop down the next thing, and you start it again. How many times does 3 go into 7? 2. And then you multiplied. 2 times 3 is 6. And then we subtract. 7 minus 6 is 1. Then you drop down the 12, or the 2, sorry, makes it 12. And then you start again. How many times does 3 go into 12? 4 plus you. And then you multiply. 4 times 3 is 12. And then you subtracted, and there was no remainder. So 672 divided by 3 was 224. Does this come back to you a little bit? I hope. It's because you've learned math so much harder than this to go back. Now you're like, oh my gosh, why did I ever think that was hard? All right, let's look at the next one, because something else happens, a couple things in this next one. So if 4 doesn't go into 1, what do I look at? Into 12. How many times does 4 go into 12? 3. And then you'd multiply. 3 times 4. And then subtract. That's nothing. So we drop down the next number, and we start again. Now, as we're going through this, notice I kind of keep saying the same things over and over and over. I do that because I'm trying to get it stuck in your head, because it's the same process when you're going through with polynomials. Okay, so I just want you to really kind of recognize the process here. How many times does 4 go into 5? And then we multiply. 1 times 4 is 4. And then we subtract. That's 1. Drop down the 3. And we start again. How many times does 4 go into 13? We multiply. 3 times 4. And then we subtract. That's 1. Drop down the next number. We start over. How many times does 4 go into 16? And we multiply. 4 times 4, 16. We subtract. That's nothing. Drop down the next number. How many times does 4 go into 3? 0. We multiply. 0 times 4 is 0. And subtract. That's 3. Drop down the next number. How many times does 4 go into 35? 8. Then we multiply. 8 times 4, 32. And then subtract, and that gives me 3. What do I do with the 3? Oh, I knew somebody would say it. R3 is very elementary. All right, anytime you have a remainder, we turn it into a fraction with whatever it is you were dividing by. It's 3/4. That one was a lot harder. I mean, there was more steps too. But the big idea with all of this is that you understand the process, right? You look and see how many times it goes in, you put the number at the top, you multiplied, you write it down, and then you subtract it. Drop it down, and we start over, right? It's the same process over and over and over. So let's look at that process with polynomials, okay? So divide, use long division. The f of x, what does this really mean? It's like y equals, so I don't have to worry about that. I want you to take this, and we're dividing it by that. See the by? Divide by that. So which one goes under the radicand? It's called a radicand. Good. The 6x squared plus 7x plus 2. We're dividing by 2x plus 1. And already, are some of you panicking? It's not bad. I promise. It's not that bad. Just don't give up on me right from the start, okay? Now, when we start, I'm only looking at the first term here and the first term here. I'm ignoring the rest of it for the time being when I first start, okay? Instead of me asking you how many times does this go into this, I'm just going to ask you, what do you multiply 2x to make 6x squared? 3x. Okay? That's how we start. Looking at what do you multiply this to make this? It should always work where it actually, you can multiply it by something nice and make it work. Okay? All right. Then you will multiply, just like we did before, 3x times 2x, 6x squared. Now here's where the rest of it comes in, because you're going to distribute to the other term as well. 3x times 1 is 3x. So I'm still doing the same process as before, except I have to distribute it because I have two terms that I'm dividing by, right? It gets distributed to both. Now, what was your next step before? You subtract. What happens when I try to subtract an entire piece? What happens when I subtract an entire piece? What's the negative out in front of that thing do to it? It's like a -1. So what's it do to all my signs? It changes all my signs. So it's going to make that -6x squared, and it's going to make that a -3x, right? Because this is like -1. When it distributes, it changes all your signs. So you're going to hear me, instead of saying subtract, you're going to hear me say change your signs. Right. So if that was a negative to begin with, it would change it to a plus. Yep, that's why I said change your signs. Yep, it's going to flip them all. Say that again. Not in this one, because I'm not subtracting two negative. I'm subtracting two positive, which made them negative. But these are all positives. I'm not subtracting negatives, though, because now it's just 6x squared minus 6x squared. Don't throw an extra sign in there. Okay, yeah, I used my sign to change them both to negatives. They change to their opposites. Hang with me. We'll do lots of examples. You'll get it. Yeah, hang with me. So what happens to 6x squared minus 6x squared? Cancels. That should happen every time. If it doesn't, you did something wrong. Okay, we want that to go away. And then 7x minus 3x is 4x. Bring down the rest of it, and we start over. What do you multiply 2x to get 4x? Just 2, a positive 2. And then we distribute it. 2 times 2x, 2 times 1. Then what? Change your signs. So in this case, that's going to change to a minus. That one's going to change to a minus. And I'm only changing that bottom row because if you think about long division, I'm only subtracting the bottom. So the bottom changes. So then 4x minus 4x, 2 minus 2, so there's no remainder. so it's 3x plus 2. Now, I want you to see what you just did. I want you to understand this. They gave you 2x plus 1, and when you divided it, you got 3x plus 2. Look at this. Look at that. What did you just do? You factored. They gave you one of the factors. When you divided it, you found the other factor. Yay! It's an annoying way to factor. Now, could you have done that just by factoring that? Yeah, you could have. Now, does everything I give you, is it able for you to factor it? If I gave you something with 5 terms, do you know how to factor that? Mm-mm. So what happens is, if we can get at least one of them, then we can turn it into something a lot of times that then I can factor. And that's part of tomorrow's lesson. The 9 of you I'm going to be missing that you'll want to watch a video on if you're missing tomorrow. Okay? Let's look at another one. We got to get this process down. Yeah?
So, why do we, were supposed to get laptops on?
You weren't. It was my financial class.
We got text messages, though. On our laptop.
Really? It went out to you guys?
Yeah.
Oh. It must have been, I don't, maybe I accidentally clicked the wrong one. I meant to send it to my financial class. If it went to you guys, I apologize.
All right. It's like,
Yeah, I'm sorry. If it did, it was not meant for you guys. It was meant for my financial class. Sorry.
It actually even said on here too, it looks like it's sponsored by Possible Foods or Headphones.
Yeah, it was meant for my financial class. Yeah, sorry. That's what happens when you multitask from home. All right, so let's go ahead and try this one. So x cubed plus 5x squared minus 7x plus 2 dividing by x minus 2. All right, so what am I looking at to start? Which ones? Good, the x and the x cubed, just the first ones. What do you multiply x to get x cubed? X squared. All right, and then we're going to distribute it. X squared times x, x cubed, and x squared times negative 2, negative 2x squared. What's your next step? Change your signs. And again, it's only going to change this bottom row. Now notice this time, the first one changed to a minus, but the second one was a minus, so we changed it to a plus. It's always flipped them to their opposites. So then x cubed minus x cubed cancels, as it should. If it doesn't, you did it wrong. And then 5x squared plus 2x squared, 7x squared. Now, you could bring down just the next thing if you want. Me, personally, I kind of bring down everything as I go, because some problems get a little funky, and like there's not like terms, and it gets kind of weird. So for me, I just kind of bring everything down as I go with me. All right, and then we start over. What do you multiply x to get 7x squared? 7x, a positive 7x. Let's make sure you put the plus at the top. All right, distribute 7x times x. And 7x times negative 2. Then what? Change your signs. If you're going to mess up anywhere, you're going to forget to change those signs. It should. If it doesn't, you did it wrong. Yep, every time. That's kind of nice. That way, like, really look at your signs, because if you don't have it canceling, you probably did something wrong. You want to go back and take a look at that. All right, then you have negative 7x plus 14x. Okay, positive 7x. Bring down my plus 2. Now we start again. What do you multiply x to get 7x? Positive 7. And we distribute 7 times x. 7 times negative 2. Okay, then what? Change your signs. So that's a minus. That one's going to change to a plus. 7x minus 7x. There, that canceled again. And then I have 2 plus 14, 16. I got nothing else to bring down. Can I multiply an x to get 16? No, it means I'm done. If I can't actually make that work, I'm done. So this is my remainder. Do not write r. right? Plus, we always add those remainders on. It'd be 16 over x minus 2. Whatever you're dividing by is your remainder. So was x minus 2 a factor of that problem then? If you get a remainder, does that mean it's a factor? No, it's not. Just like if I asked you, is 2 a factor of 10? Can I do 10 divided by 2? Yeah, it's a factor because 2 times 5 is 10. Is 3 a factor of 10? No, because you'd get a remainder. You couldn't divide those nicely. There's not 3 times something pretty to give you 10. Okay? Oh, there's a big fraction. What's a fraction mean? It means divide. It's amazing to me how many students don't recognize that a fraction bar really just means divide. So let's go ahead and set it up. 3x to the 4th minus 5x cubed plus 4x minus 6 divided by, oh, it's a long one, x squared minus 3x plus 5. So what's going to happen when I go to distribute? I'm going to have to distribute to 3 terms this time because there's 3 things I'm dividing by. But as always, start with just the first ones. So what do you multiply x squared to get 3x to the 4th? 3x squared. Okay, so then we distribute 3x squared times x squared. 3x squared times negative 3x. I'm at the middle one. 3x squared times negative 3x. Negative 9x cubed, good. 3x squared times 5. Then what? Change your signs. And that changes all of them along that bottom row that I just did. All right, 3x to the 4th minus 3x to the 4th, as it should. Negative 5x cubed plus 9x cubed. 4x minus 15x squared. Oh. Are those like terms? I can't put an x with an x squared. So it's going to just be minus 15x squared plus 4x. And then I have the minus 6. That's one thing with long division you got to be careful about is your like terms, a lot of times they line up as long as it's in standard form, but sometimes they don't. Notice here it went from like x to the 4th, x cubed to x to the 1st. It skipped an x squared term. When things are missing like that, sometimes they don't always line up nice and neat. Not in standard, write it. This one is standard, but it's missing that x squared term, so there's just nothing I can do there. All right, so start again. What do you multiply x squared to get 4x cubed? 4x squared. Or 4, not x squared, x. Because I already have 2 of them. I just need another x to make it cubed, and I needed the 4. All right, so we distribute 4x times x squared. It's 4x cubed. 4x times negative 3x. 12x squared. And then 4x times 5 is 20x. Then what? Change your signs. It's obnoxious for me to keep saying it, but I know that's where you're going to mess up. You'll forget. All right, the 4x cubes, those will cancel. Negative 15x squared plus 12x squared. 4x minus 20x. And then we have the minus 6. And we start again. What do you multiply x squared to get negative 3x squared? Just negative 3. If you made it positive, you'd have a positive here, and then when you change your sign, it'd make it negative. Negative 3 minus 3 is not nothing. Yeah, you always want to try to match it to be exactly what it is so that when you change all your signs, it then cancels. All right, so here we go. So negative 3 times x squared, negative 3x squared, negative 3 times negative 3x, say positive 9x, and then negative 3 times 5, negative 15. Change your signs. Now, every year I have some students who try to change their signs while they're multiplying. Please don't do that. Okay, that just, it becomes a nightmare and you miss one of them and the whole thing's wrong. The way I'm showing you how I go through and then I kind of go back and change my signs, I still do that. If you watch my answer keys, you'll still see my like scribbled out plus signs when I write a minus above it. I still do that. Even I don't change them as I'm going. You make too many mistakes. All right, those cancel. That's going to give me negative 25x, and that's what, positive 9? All right. Can I multiply x squared to get negative 25x? No, I can't do that. So what's that mean? Good. That means I'm done as far as dividing goes. This is my remainder. We always add our remainder, so plus negative 25x plus 9 over x squared minus 3x plus 5. That is an ugly problem. So was this a factor of the original problem? No, it was a remainder, so it's not a factor. And I ask that question quite often. Is that a factor? No, it's not. How are we feeling with long division so far? You okay? Yeah. Do you need the work at the bottom? Here it is. All right, those of you who are ready, go ahead and try number 4 on your own. Just when you write the problem, make sure it's written in standard form. That one's not started out in standard form, okay? Yes, you may. Okay, make sure you write in standard form on number 4. And then you guys can try it on your own. All right, so as long as you recognize you had to put it in standard form, hopefully this one wasn't too bad. What did you multiply x by to get 4x squared? 4x. All right, then we distribute. You get 4x squared plus 20x. Then you have to remember to change your signs. So that cancels. This gives me 3x. Bring down the minus 16, and you start it over. What do you multiply x to get 3x? 3. Distribute. So we get 3x plus 15. Change your signs. That cancels. We get negative 31. That's my remainder, so plus a negative 31 over x plus 5. So is x plus 5 a factor of that problem? No, it is not. Good. You guys are doing really well. Questions on that one? Did you see what happened? You guys are awesome. All right. Is x squared plus 1 a factor of that problem? How do you tell? If you divide and you get no remainder. So a polynomial is a factor if the remainder is 0. So if there is no remainder, then you know that it is a factor. And recognizing that and understanding that will help you in the next couple sections too. Okay. All right, so notice something real quick. And I'm going to teach you guys some synthetic today since I won't see a lot of you tomorrow. Notice this goes x to the 4th, x cubed, x squared, and it jumped to 5. What's it missing? It's missing the x to the first term, right? If they stair step down. When we do synthetic division, that is huge, that you have to recognize that. Okay? The fact that it's not there with long division isn't bad, but then your terms may not line up exactly at some point. Okay? All right, so let's go ahead and try it. So 3x to the 4th minus 4x cubed plus 12x squared plus 5. We're dividing that by x squared plus 1. All right, so what do you multiply x squared to get 3x to the 4th? 3x squared. So 3x squared times x squared is 3x to the 4th. And then 3x squared times 1 is 3x squared. Then what? Change my signs. So be careful here. My 3x to the 4th cancel. I have an x cubed, and underneath it I have an x squared. So negative 4x cubed just comes down. But do you notice these are like terms? Yes, we can combine them. 12x squared minus 3x squared is 9x squared plus 5. Again, notice what I'm dividing by. I'm dividing by an x squared and then a 1. It also was missing the x to the first term. So it kind of throws everything off. All right, let's start over. What do you multiply x squared to get negative 4x cubed? What? Negative 4x. Just x, yep, just x. All right, so the negative 4x times x squared, negative 4x cubed, negative 4x times 1, negative 4x. Then what? Change your signs. The 4x cubes cancel. And be careful, what do I have left? I have 9x squared. Good. None of those are like terms. So they all just kind of come back down in standard form for us. Can I keep going? Can I multiply x squared to get 9x squared? Yeah, so I'm going to keep going one more time. That would be a 9. Do I need an x? No. All right, so then 9 times x squared is 9x squared. 9 times 1 is 9. And then change your signs. So that canceled. I have 4x, and then 5 minus 9 is negative 4. And then can I multiply an x squared to get a 4x? No. So if I can't do that, I know I'm done. That is my remainder. So plus 4x minus 4 over x squared plus 1. So the question asked, is x squared plus 1 a factor of that? No. It is not a factor because there was a remainder. All right, questions with long division. Okay, I want to show you synthetic division so you can see the difference, and because I won't see a big chunk of you tomorrow. Okay, I want to make sure you learn that part from me. We'll go ahead and skip that one. Let's talk about synthetic. Now, homework tonight is just a long division practice. That's what we're working on for homework tonight. If you will not be here tomorrow, I will also give you tomorrow's homework with synthetic division on it. Tomorrow you'll have to do synthetic division and then also factoring after you divide. I may or may not show you an example of that. We'll see how things goes here, just so you guys know. All right, so synthetic is so much faster. It almost seems ridiculously easy once you get going with it, but it has a limitation. When I'm dividing, it has to be in this form. It has to be x, technically it could be plus or minus some number. So if I'm dividing by x squared and then a number, like the last problem I just did, I can't use synthetic division. If I'm dividing by 3x minus 5, I can't use synthetic. Okay, it has to just be x and then plus or minus a number. Now, it happens a lot. When we get further into the next section, that happens a whole lot that shows up. Okay, so don't think I'm teaching you something that you won't use much. You'll use it more than long division. All right, so kind of here's our step-by-step, and then I'm going to talk you through this, and your mind's going to be blown, but just kind of hang with me, okay? So first, you're going to write the coefficients. What are coefficients? Uh-oh. Those are the numbers in front of x, like 4x squared. 4 is a coefficient, okay? It's a number in front. All right, including zeros. So we kind of talked about how that one like jumped and didn't have the x to the first. You'd have to put a 0 if it's missing something. That's probably the hardest thing of synthetic is just remembering those missing things. Make sure it's in standard form. Omit all variables and exponents. What's omit mean? What? Right, don't include it. Just forget about it. Don't even write those down. And then for the divisor, you use the opposite sign of A, or for me, it's easier to think of it this way, the answer. If set equal to 0. Right, like if I gave you guys x minus 4, what does x equal? 4. That's what you would divide by. To me, that just makes more sense than telling you to use the opposite sign of A. You are using that, but like we've talked so much about solving, it makes more sense. It's just the answer if you set that equal to 0. Okay. Just hang with me, okay? We are dividing by x minus 2, which is in that form. It's just an x and then a plus or minus a number. So it works. So let me kind of show you something. First, my first instinct is always looking to see if anything's missing. I have x cubed, x squared, x to the first, and then my constant. I have everything. I don't have anything missing. Now, coefficients, there is a 1, and then a 5, -7, and 2. Okay, just leave a little space in between so you can keep track of what numbers are what. Now, normally your radicand, you know, think about how that went. This one's almost upside down of that. Leave a little space underneath. I told you this is something like you've never seen before. This is every bit algebra 2. Long division, I used to teach in algebra 1. Synthetic, all algebra 2. What does x equal here? X equals 2. So I am dividing by 2. I know this is weird. The first number, you always drop straight down. And I put an arrow there just as a placeholder so I don't accidentally put my numbers in the wrong spot. No. It's very weird. It really is. Hang with me. You'll like it once you do a few of them. All I'm doing is adding and multiplying. That's all I'm going to do. Okay? You multiply first. What's 2 times 1? And then add. What's 5 plus 2? And then we're going to multiply. What's 2 times 7? 14. And then we're going to add. What's -7 plus 14? Then we're going to multiply. What's 2 times 7? And then we're going to add. 2 plus 14 is 16. I'm almost done. Chris, you with me? Good morning, sunshine. All right, we are always dividing out just a single x right here, right? I told you it had to be x. It couldn't be x squared. It had to be just an x. So like if I'm dividing out an x, all of my exponents are going to drop by 1 because I'm taking 1 out. So if this started as a 3, just going to drop by 1. This is going to be an x squared. That's a +7, and then I'm going to put in an x. I'm stair-stepping these down. 7 is my constant. That means what's 16? Over x minus 2. It's my remainder. But that came from x minus 2. Now, I know this is weird. Like, that was really weird, right? It took up a lot less space. Let me show you. You can write it down or not. Let me do this problem again in long division so you can see the similarities, okay? Because it is really cool how it all works. So I'm going to do it over here, just kind of written a little smaller, just so we can see it. So it's x minus 2, and it was x cubed plus 5x squared minus 7x plus 2. All right, so if we did long division, what do you multiply x to get x cubed? X squared. Then you multiply x squared times x, x cubed. I gave you -2x squared. And then what did you have to do? Change your signs. Don't tell me you forgot already. That would give me 7x squared. I bring everything else down. and then you start it over. What do you multiply x to get 7x squared? 7x. You seen your answer show up here? 7x times x, 7x squared. 7x times negative 2 is negative 14x. Change your signs. Negative 7 plus 14 gives me 7x, and then plus 2. And we start it over. What do you multiply x to get 7x? 7. And you multiply 7x, negative 14. Change your signs. We had 16, which would be up here as my remainder. Same answer, way less work doing synthetic. Did you kind of see some of these numbers show up, though, as I went through and did this? Here's that 5 and 2. There's the negative 7 and the 14. There's the 2 and the 14. They're all there. X plus or minus a number. If it's x squared, can't do it. Weird, right? But kind of cool. Come on, nobody's amazed by that? I mean, I don't know. That's a good question. I don't know how somebody thought of that. Yeah. Oh, did you try one on your own? Yeah, so let's look at the next one. So first thing, make sure it's in order. So I have an x cubed, x squared, x to the first, constant. You always want to make sure you have a constant. Don't lose that part. All right, so we can do synthetic. We have 1, negative 14, 51, and negative 54. What am I dividing by? Negative 2. Because x would equal negative 2. Drop the first one down. Do you see why I put an arrow there? You don't want to accidentally put a number there that doesn't need to go there. Multiply first. So negative 2 times 1. Negative 2. And then we add. What is negative 14 plus negative 2? Then we multiply. Negative 2 times negative 16. 32. And then we add. Gives me 83. Multiply negative 2 times 83. It's negative, was it 166? And then we add. That's negative, thank you. Yikes. So before I even finish, is x plus 2 a factor? Is there going to be a remainder? Yeah, there's a remainder. The big ugly remainder. All right, so this one started x cubed, which means this one will start x squared. It always drops down by 1 because I divided out an x. Minus 16x plus 83, this is my constant, which means this part has to be my remainder over x plus 2. Oh, yeah, I got to bring it down first. That'll do it. But, like, what do we think about this process, though? Kind of cool, yeah? No? Yes? I think it's cool. Why don't you guys try number 9 on your own? All right, so filling in your numbers, you'd have 2, 1, negative 8, and then 5. Make sure you don't lose your negative. And then what would x equal? Negative 3. All right, drop down the first number, whatever it may be, drop that straight down. And then we're ready to multiply. Negative 3 times 2. And then we add, what's 1 plus negative 6? It's negative 5. Multiply negative 3 times negative 5. Negative 3 times negative 5, positive 15. That's going to give me a positive 7. Negative 3 times 7, negative 21. 5 and negative 21, negative 16. All right, since this started x cubed, this one is x squared. And then this is x to the first. This is my constant, plus, that means this is my remainder over x plus 3. Now, the one thing I want to point out to you guys when you're doing this, you have a red flag if you did something wrong, okay? Every problem you do with synthetic, it will stair step down all of your x's. You will have a constant and a remainder every time. Okay, like I saw someone who had an answer who did this, 2x cubed, they did 5x squared, 7x, and they were like, oh, that's my constant, I'm done. Red flag, I want to point this out to you so you can kind of catch yourself. You always have a constant and a remainder. Is it possible the remainder is 0? Yeah, if it's a factor, the remainder will be 0. But there will literally be a 0 there, okay? Like there is always something for constant remainder. So that should be your red flag. If you get all the way through and you're like, I don't have anything in place of my remainder. Like red flag, you should. Even if it's a 0, there should be something there, okay? It's kind of a red flag that you lost something. Let's look at number 10, and this is where typically students lose things. Look at the original problem. Is it missing something? It's missing the x squared. Now, with long division, we're like, okay, and like you just got to kind of watch for your like terms not to line up. Here, if you forget it, it's completely wrong. Like 1 is the coefficient on the first one. I need to put a 0 for the x squared. Then I have negative 57, and then I have a 56 for the constant. If you do not put the 0, it is very, very wrong. Right, and what does x equal? X equals 7. So that's what I'm going to use over here. All right, drop the 1 down. And it's funny, I have a 1 and a 0 to start off with. This is where more people make mistakes. They don't know how to multiply and add with 1s and 0s. What's 7 times 1? What is 0 plus 7? Thank you. I've had so many people tell me 0. And then 7 times 7. Negative 57 plus 49. 7 times negative 8. 56 minus 56. And we're done. All right, let's put my x's back in. It started x cubed, so this is x squared plus, where's my x to the first? This is my constant, and this is my remainder. You will always have something in place of it. So in this case, is x minus 7 a factor of that? Yeah, it is. All right. One of the things we are going to look at tomorrow, so the 9 of you who will not be here, real quick, let me just kind of show you. I'll just show you on this problem. So tomorrow we're going to look at problems where you couldn't have factored them to start with. Like if I just gave you this original problem and I asked you to factor that, you can't. Like you would have, there's no way for you guys to know how to factor that, right? You're like, it's 3 terms, so that would be your plain old regular factoring, but I can't go x squared and x squared or x and x because there's a stinking x cubed there. Like it doesn't work. So like you don't know how to factor it. So what happens is, in this case, I'm giving you one of the factors. Later on into some other sections, we will have to find those other factors by using the graphing calculators, okay? But tomorrow we're going to work on, once you use the one I gave you, finish factoring the whole problem. So this problem right here, can you factor that?
Well, yeah, because here's the 0.
Yeah, so we got x and x. And you're right, I have a 0 at the end, so I know it is a factor. Plus and minus. 1 and 8 or 2 and 4? 1 and 8. Which one's positive? The 8. 1 and 8. Is this the fully factored answer right here? Would this get me all the way back to the beginning? No, what am I missing? The x minus 7. That is the fully factored answer. So tomorrow, those of us that are here, that's what we're going to focus on. Do your division, whether it's long division or synthetic, because I can't use synthetic for everything. Do divide first, get whatever you get for the answer. If I tell you to factor, it should get a 0 for a remainder. And then take the answer you get and factor farther. Does that make sense? Those of you who will not be here tomorrow, that's what we're going to focus on tomorrow. Those of you that are here, if you're not sure what I'm doing, I'll talk more about it tomorrow. All right, I want to go ahead and stop there. So at least those of you not here tomorrow have something to kind of take with you so you can get things done. Let me give you homework tonight. Tonight is just long division homework. Just long division, okay? If you want, I'll put my answer key out so you can kind of check as you're going with long division, because those are harder. Like if you get it wrong and you're just like, or you walk up and you're like, is this right? You know how long it takes for me to check those? A while, because I got to like go through all your math and find your signs and see what's going on. So if you missed it and you don't know why, ask me, but don't ask me if it's right or wrong. I'll set my answer key out. Yes?
I've gone over this. Is the synthetic, what are the restrictions on when you cannot use synthetic division?
Synthetic division, you have to have just be dividing by x and plus or minus a number.
Okay.
If I have 2x, can't do it. If I have x squared, can't do it.
Okay.
But if it's just x and then plus or minus a number, I can use synthetic.
So, are we going to be able to use synthetic division on most of the questions tonight?
Tonight is long division. Like, I want you to do long division on all of them. Even if you can do synthetic, because normally I don't teach them on the same day. I'm only doing that because I'm losing a lot of you tomorrow.
Because synthetic division is actually a lot easier.
Yeah, and it's fast. That's why I like synthetic. It's super fast. It's easy. But it doesn't work on everything.
Right.
Yeah, so tonight, I'm glad you brought it up, though. You must use long division tonight. On your quiz and test or wherever I don't know if I'm giving you another quiz or not. But anyway, on your test for this chapter, I will literally ask you to divide, use long division on 2, use synthetic division on 2. So you're going to have to know how to do both. Plus, I'm going to give you problems like something like this one, where I ask you to factor completely after you divide. So you're going to have to decide, can I use synthetic or do I have to use long division to divide first and then factor what's left? Okay, so you have to make sure you know the difference between both of them.